Along Central America's Pacific coast, from southern Mexico to Costa Rica, the ocean seems calm. But deep beneath the surface, the Earth is shifting in unsettling ways. Subtle tremors, some barely perceptible, others strong enough to rattle cities, have been rising from the seafloor in recent years. To scientists, these aren't random. They're warning signs, part of a larger, more troubling picture. Lurking just offshore, hidden beneath thousands of kilometers of ocean, lies the Middle America Trench, a massive undersea fault few outside the scientific community even know exists. But to geologists, it's one of the most volatile subduction zones on Earth. While some segments of the fault have released tension in bursts, others have remained eerily quiet, locked in place for decades. Deep, low-frequency quakes, creeping ground deformation, and migrating stress suggests that pressure is now shifting toward these silent zones. With pressure mounting deep beneath the seafloor, a chilling question looms. Is the Middle America Trench on the verge of a catastrophic rupture? Let's find out. Don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. The Middle America Trench stretches for approximately 2,750 kilometers, running parallel to the Pacific coasts of Mexico, Guatemala, El Salvador, Nicaragua, Costa Rica, and parts of Panama. It marks the boundary where the oceanic Cocos Plate and Nazca Plate subduct beneath the continental North American Plate and Caribbean Plate. This trench is a quintessential example of a convergent plate boundary, where denser oceanic crust is thrust beneath lighter continental crust, creating the conditions necessary for high-magnitude megathrust earthquakes. The subduction process not only forms deep oceanic trenches, but also gives rise to volcanic arcs, mountain building, and seismic activity. In this case, the Middle America Trench has helped shape the Central American Volcanic Arc, a chain of active volcanoes that runs inland along the subduction zone. This arc includes well-known peaks such as Volcán de Fuego in Guatemala, Momotombo in Nicaragua, and Arazu in Costa Rica, each a vivid reminder of the dynamic forces at play beneath the region. The trench itself reaches depths of up to 6,660 meters, and the plate convergence rate along its length varies from 5 to 9 centimeters per year. These seemingly small movements accumulate vast amounts of strain over decades or centuries, which can be released in sudden, violent earthquakes. The subduction zone is geologically complex. The northern portion, particularly off the coast of Mexico, is characterized by tightly locked fault segments. These segments accumulate tectonic stress over long periods and are prone to sudden rupture. In contrast, the southern segments near Costa Rica and Nicaragua display a different behavior: frequent slow slip events and tremors, which suggest some areas may relieve stress gradually. However, this process is uneven and may transfer stress to locked segments, increasing their potential for a major rupture. The Middle America Trench has a long and destructive history of seismic activity, producing several powerful earthquakes with devastating human impact. In 1973, a magnitude 7.0 earthquake struck near Veracruz, Mexico, killing more than 600 people and causing widespread damage. This was followed by the 1985 Mexico City earthquake, one of the deadliest in the region's history. Although the epicenter was nearly 350 kilometers away, seismic waves were amplified by soft soils beneath the city, resulting in over 10,000 deaths. Another notable event occurred in 1992 off the coast of Nicaragua. This magnitude 7.7 earthquake generated a tsunami that struck the Pacific coast, causing over 100 deaths and substantial destruction. What made this event particularly alarming was that the quake was preceded by little foreshock activity and was not immediately recognized as tsunami-genic. Similarly, in 2001, El Salvador experienced two large earthquakes within a month, magnitude 7.6 and 6.6, causing landslides, widespread damage, and over 1,000 deaths. By 2012, large earthquakes in Guatemala and Costa Rica ruptured different segments of the trench, further revealing its segmented and unpredictable nature. Each event has demonstrated that while one part of the fault may rupture, others remain silently locked, storing energy for the next disaster. Seismic behavior along the Middle America Trench has intensified in recent years, with both powerful earthquakes and subtle tectonic shifts drawing renewed scientific attention. One of the most significant recent events was the 2017 Chiapas earthquake, a magnitude 8.2 earthquake that struck off the southern coast of Mexico. Although it occurred within the Cocos Plate, making it an intraslab rather than a megathrust earthquake, it was one of the strongest ever recorded in Mexico, causing nearly 100 deaths and highlighting the region's vulnerability. In 2022, a magnitude 6.9 earthquake off the coast of Guatemala, though more moderate, struck at a shallow depth and was widely felt, demonstrating the risks posed by even smaller events near populated areas. In addition to recent quakes, scientists have observed a rise in slow-slip events and low-frequency tremors, especially offshore Nicaragua and Costa Rica. These subtle, silent movements suggest parts of the fault are shifting gradually, while other segments remain locked. Scientists now warn that several segments of the Middle America Trench may be nearing a critical rupture. Areas like the Guerrero Gap in southern Mexico have not experienced a major earthquake in over a century, despite showing high levels of strain. Similarly, increasing seismic tremors off the Guatemalan coast suggest growing instability. A sudden rupture could trigger a cascading megathrust earthquake, with magnitudes exceeding 8.0. A megathrust earthquake along the Middle America Trench would be catastrophic. Coastal cities such as Acapulco, Puerto Escondido, Puerto Quetzal, La Libertad, and Corinto could face severe ground shaking, leading to collapsed buildings, destroyed roads, and mass casualties. Mountainous regions of Guatemala, El Salvador, and southern Mexico are particularly prone to landslides, which could bury communities and block key transport routes. Perhaps the most terrifying threat is that of a tsunami. The 1992 Nicaragua quake, much smaller by comparison, caused a deadly tsunami. A larger rupture could produce waves over 10 meters high, striking low-lying coastal zones across Mexico, Guatemala, El Salvador, Nicaragua, and Costa Rica within minutes, well before many could evacuate. In extreme cases, these waves could cross the Pacific, reaching distant shores like Hawaii or Japan. Secondary disasters such as fires, dam failures, and widespread infrastructure breakdowns would further complicate rescue and recovery efforts. Economic disruption would be enormous, especially if vital trade ports like Puerto Quetzal and Lázaro Cárdenas are damaged, affecting regional and even international supply chains. In short, a megaquake here could paralyze an entire region in a matter of minutes. Recognizing the seismic threat posed by the Middle America Trench, regional governments and scientific institutions have made significant efforts to improve monitoring and preparedness. National seismic institutes in countries like Mexico, Nicaragua, and Costa Rica maintain extensive monitoring networks that include seismometers, GPS systems, and ocean bottom sensors to detect both rapid and slow tectonic activity. International partnerships, including those with the U.S. Geological Survey and Japan Agency for Marine Earth Science and Technology, have advanced research into subduction dynamics. These collaborations have uncovered episodic tremor and slip events, which may offer early warning signs of major ruptures. Satellite-based tools like INSAR are also helping scientists identify areas where stress is silently building. On the civil side, countries like Mexico and Costa Rica have adopted earthquake-resistant building codes and conducted public drills and education campaigns. However, gaps remain, particularly in rural and low-income communities, where infrastructure and access to early warning systems are limited. Tsunami alerts, via sirens and mobile networks, exist in some coastal areas, but coverage is inconsistent. While progress has been made, further investment is needed to ensure equitable protection and resilience across the entire region, especially as seismic risks continue to grow. The Middle America Trench will remain one of the most closely watched seismic zones of the 21st century. As tectonic plates continue to converge beneath the Pacific, the accumulation of stress along locked segments is inevitable. The recent rise in slow slip events and tremor activity offers critical data, but also signals mounting instability in adjacent fault zones. While pinpointing the exact timing of a megaquake remains impossible, modern tools like real-time monitoring, satellite imaging, and historical analysis are improving risk forecasts. Looking ahead, the path to resilience lies in action. Regional governments must strengthen early warning systems, enforce seismic building codes, and invest in public education. Past disasters have shown that preparedness can save lives and limit damage. International cooperation will also be key. Earthquakes and tsunamis know no borders. Shared data, funding, and coordinated emergency responses will be essential for a safer future. The Middle America Trench is a formidable geological force, but it is also a wake-up call. Though we cannot stop the Earth from moving, we can choose how we respond. With science, infrastructure, and collective will, Central America can face what lies ahead, ready, informed, and resilient.